Okay, so this lesson is about present value. And if we go back to the previous lesson, go back to the top. It was all about what you start with, which we call the principal, and then what you end with at the end of an investment, how much it grows to. And so this is called future value. So what we're going to talk about today is present value. And this is the kind of situation where you have a future amount that you're trying to invest to grow to. So maybe you want $10,000 in 10 years. What do you have to invest now, right? So it's sort of backwards from the last one that we did. And we're going to figure out what the formula is using the previous formula. So we are going to divide by, which is a little bit strange. Whoops. We're going to divide by that part because we're going to try to solve for principal. And I'm just going to flip the sides here. And in a way, this is already a formula, but we can simplify it a little bit with some of the stuff that we learned back a couple of units ago by saying that this thing in the denominator with an exponent, I can bring it up and make it a negative exponent. Okay, so this is a formula. And another one that we would have to remember. Sometimes we talk about, like we've been using A and P for principal and final amount, but we also use present value and future value. So how much we have in the present compared to how much we have in the future, but everything else is the same, 1 plus I. And similarly, we could change the formula that we used yesterday to be with present value and future value. So, I'll kind of go back and forth using both different formulas, but, it means the same thing. PV stands for present value, FV stands for future value. All right, so first question. This is the kind of question that you would see that is a present value question. Natasha is 14 years old. She wants to buy a car when she turns 17. So she has an amount of money, a goal that she set that she needs to have, looks like in 3 years. Okay. And so how much does she have to invest now so that it will grow to that amount in 3 years? And tomorrow we're going to compare present value questions and future value questions, and kind of like we did back with exponential growth and exponential decay. Eventually, you're going to have to decide, well, which one is this? And it's a little bit harder sometimes with financial math, especially when you get into the grade 12 component that includes mortgages and annuities and that kind of thing. Hopefully it's not too hard in this course, but it is a little bit more complex just because of the wording. Sometimes it's a little bit awkward. So that's something that we're going to talk about tomorrow. And that will be the focus of tomorrow is what are you really solving for? Is it a future value question? Is it a present value question? And actually, we're going to explore some other kinds of questions as well. But this one, obviously, everything we're doing today is present value. Okay, so she needs $3,000 in the future. how much does she need now? So that's what is her principal that she needs. So again, we're going to list all the variables, right, and then fill them out. So the principal, the original amount, is now what we're solving for. The final amount is that $3,000 that she wants. 3.7%. And compounded monthly. Whoops, put that in the wrong spot. And 14 years to 17 years is 3 years. Again, times the compounds per year, which is monthly, so 12. And that's 36 compounds. Okay, subbing everything in. And then we just put it into the calculator. And that negative 36 is going to be really important that you put it in as a negative. I'm going to go back to that in a moment. Okay, so she needs to invest or to deposit that amount. This is the amount that she needs today in order to save for $3,000 in the future. This goes back to this idea of like if we forgot the negative, this goes back to that idea, is this exponential growth or exponential decay? So it doesn't make sense that she would have to deposit $3,300 today in order to save for $3,000 in the future. That's not how interest works. So if you get an answer that doesn't make sense for the situation, you can always go back and think, whoa, what did I miss? And in this case, it was the negative for the exponent. But when I put the negative in, then I get a number that's smaller and, you know, in the ballpark again, like we talked about. It's a reasonable answer, so it makes sense. What is the present value of $50,000 10 years from now? Oh, yeah, 10 years from now at 2.5% compounded quarterly. So again, it's a little bit of awkward wording, but it does just come out and say present value. So $50,000 in 10 years, what is it worth today? Okay. So we're looking for present value. The future value that we're looking for is $50,000. Again, this would be an appropriate down payment for a house, something like that. So somebody is wondering, what do they have to deposit now to save up for $50,000 in the future? 2.5% compounded quarterly. Okay, then we sub in. and then we just put it into our calculator. And again, I would encourage you to try this on your own, um, so that you know how to put these into your calculator. Okay. Notice that I'm not even using that fancy fraction button on the calculator. BEDMAS will divide first and then add, so it is actually just as easy to do it this way. Okay, so this is a really good example of how people who work with money, so people who invest, or bankers or financial advisors, that kind of thing, think about money. $50,000 10 years from now is worth 38,000 or about $39,000 today. Um, so about $39,000 today will grow to $50,000 in the future. Again, it's at this interest rate, it's at this compounding period, and those things can change. But that's a good example. That's a lot of gain in 10 years. You've made $10,000. And that interest rate is a reasonable one that you might be able to find with some kind of specific investment, not just a savings account, not just depositing it into your bank account, but in a true investment. 3.7% is very reasonable return on your investment. So um, that's the kind of investment that somebody might really make, right? And it's a good sort of overview of how people invest and how your money can grow and your money can work for you if you invest it appropriately. Okay, one more. Okay, so I would encourage you to try to pause the video and try this one on your own. Okay, but it's going to be the same thing. It's a present value question. Um, it's a little bit different, and if you read through the three different questions, you can see how the wording is not always all the way straightforward and how you can confuse present value and future value. But this one talks about somebody who borrowed money from a bank, okay, to open a new business, to open a store, and the bank said you're going to have to pay back this amount in 5 years. How much did Sam borrow at the interest rate compounded monthly? And so we're just working backwards. So the last example was how much do I need to invest today so that it builds to a certain amount in the future? Whereas this one is just kind of like, a math class question where it's giving you the final amount and it's saying figure out the original amount. But that's still a present value question. Okay, so I would encourage you to pause the video and try this one on your own, and then I'll show you the answer. Compounded monthly, so divide by 12, and 5 years, so 5 times 12. Again, like we talked about yesterday, that number 12, which is the compounding period, the number of compounds per year, is what you want to use twice. You have to use it for I and you have to use it for N. Okay, now that's an interesting answer. We have actually talked about this several times about rounding, and in financial math, and specifically in these kinds of questions with present value, this kind of thing happens, where we have rounding to the third to the two decimal places. We look at the third decimal place, it's a 9, which rounds the 9 up, and the next 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 9 up, and all the 9s kind of round up. And it hopefully is clear in this kind of a question, but it is a little bit tricky where this is $60,000, right? And that amount makes sense that somebody would borrow that kind of round amount. So hopefully, if you see an answer like that with all the 9s, you're like, okay, that's $60,000. So therefore, she borrowed $60,000 to start her business. But we talked about this in a bit of a simpler example, where what happens when you have sort of 9s rounding up and you end up with a 0 in your final answer, and it can be tricky in that way, and this one's even trickier unless you kind of just notice that, oh, it's so close to 60,000, clearly that's the answer. Okay, so that's present value, and it's really just a different formula for today. Okay, tomorrow is going to be a little bit trickier because we are going to have to decide whether it's present value or future value or solving for something else. We're going to do a few other things as well. That being said, tomorrow we're going to use technology, so we're not really going to have to do the work ourselves. We're just going to have to recognize what kind of question it is. But it can be tricky, so that's sort of the focus of that.